Let's solve this momentum problem. We got a compact car with a mass of 725 kilograms. It's moving 100 kilometers per hour toward the east. Sketch the moving car. Then find the magnitude and direction of its momentum. Draw an arrow showing that momentum. And then for part B, a second car has a mass of 2,175 kilograms. It's got the same momentum. What is its velocity? So let's do part A first. So we'll do given. Well, we know that its velocity is, we know its mass is 725 kilograms. And so here's our compact car. And we'll say that this is east. East is to the right, so here's our little car. Our little compact car. And it's moving with a velocity of 100 kilometers per hour. So we drew a sketch of the moving cars that already asked for. So what are we trying to find here? We want its momentum, which I'm just going to use as P. And we want the magnitude and direction of it. We want to draw it as an arrow. Okay, so let's solve. Well, first, let's change its velocity into meters per second. We have 100 kilometers per hour. 1 kilometer is 1,000 meters. And we want to get rid of hours, so we know that 1 hour is 3,600 seconds. Right, so that cancels, and we're left with meters per second. So 100 times 1,000 divided by 3,600 equals 27.8. When you round it off, meters per second. So that's our velocity. Now we want to find our momentum. We know that P equals m times v. Now that, you just have to know that. That's our definition of momentum. The momentum of an object is its mass times its velocity. So we know its mass. Multiply that by the velocity. And you get a pretty big number, 20,000. I'll just round it off to 140. I didn't round it off enough, but that looks good to me. Or you can use, actually, let's use scientific notation. So P is equal, 2.01 times 10 to the 4. Now, what are the units for momentum? Kilograms times meters per second. And that's it. We don't have we don't have an assigned name for this collection of fundamental units to represent momentum. I don't know why. Momentum is a very fundamental quantity in physics, and it seems like we should honor some great physicist, with the units for momentum, but we didn't, or they didn't, those physics people. So that we just leave it like that. And there's my answer. Now, it wants to draw an arrow, so it's just to the east. Here's the magnitude, here's the direction. Now, I drew the velocity vector like this. You multiply it by the mass, and you get you would get a longer arrow. I'm not going to draw. I'm just going to say, there it is. There's my momentum vector. And this is east. And they just want you to draw the arrow here. We want you to see that, hey, this is a vector quantity. It has direction. Momentum has direction associated with it. Okay, now let's do part B. Now, what's given in part B? Well, we're given the mass of this bigger car as being 2,175 kilograms. But we also know what its momentum is. Its momentum is 2.01 times 10 to the 4 kilogram meters per second. That is, it has the same momentum as the smaller car. And what do we want to find? Well, what is its velocity? So let's solve. Well, we know that momentum is equal to mass times velocity. Well, if I know the momentum and the mass, I can solve for the velocity. So velocity is just equal to the momentum of an object divided by its mass. So this other car, this heavier car, has this much momentum. And it has this much mass. Okay. And notice that the kilograms cancel, leaving meters per second, as it should. And so the velocity of my more massive car is equal to 9.26 meters per second. To the east. We should put the direction, right? Because this is a vector. It's magnitude and direction. So there's my answer. Now, if I want it in kilometers per hour, I could just take this and, let's see, I'm going to multiply the 3,600 divided by 1,000. This turns out to be about 33.3 kilometers per hour. To the east. Now, that's a lot slower, isn't it? I mean, the compact car is going 100 kilometers per hour. This big SUV or whatever is going a lot slower, but it has the same momentum. So you can have the same momentum as something that is a lot more massive than you. But what do you have to do? You have to go a lot faster because it's the product of mass and velocity. This has a lot of importance, especially in football. If you're watching a football game, if you have a collision between two objects, as we're going to study next time, who's got the most momentum before the collision makes a difference. Anyway, that's it for this problem.